in this chapter, we're going to find out, do confidence intervals. And in this section, we're going to do confidence intervals for large sample size. We're going to find the margin of error. We're going to interpret the confidence intervals for the mean. And we're going to find the minimum sample size required when we estimate mu. And a point estimate is a single value estimate for a population parameter. Most unbiased point estimate of the population mean mu is the sample mean x bar. So population parameters mu, sample statistic or sample mean is the x bar. So a social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users of the website. Find a point estimate of the population mean mu. So here's my data. So we're going to pull up our calculator. We're going to pull up our calculator, and we're going to put this data in our calculator. So we go to Stat, Enter and Edit. And in L1, we will put all this data in. So why don't you pause the video right now so you can put all the data in. So there's my data, and it should be in your calculator right now. And if I want to find the sample mean of the data, instead of adding all those up and dividing by n, since you put them in your calculator, you could go to Stat, over to Calculate, Enter. One variable statistic, I put it in L1, frequency list is blank, and just go to Calculate. And my x bar, my mean is 130.8. So if you typed in the numbers correctly, you should get 130.8 for your mean. So your point estimate for the mean number of friends for all users of the website is that mean, 130.8. An interval estimate is an interval of range of values used to estimate the population parameter. So for example, instead of using just 1 point, maybe say 12.4, I would use some interval. Okay? And we want to know how confident are we that that interval contains that population mean mu. So how confident do we want to be? Do we want to be really confident, like 99% confident, or do we want to be 50% confident? The level of confidence is what I was talking about, like 95 or 50 or whatever level of confidence. In the problems in the book, they'll tell you what they are. So the probability that the interval estimate contains the population parameter. That's your confidence. And remember the normal curve? C is in the middle. So if you want to be 95% confident, this area here would be 0.95. And if you want to be 95% confident, that would mean your two tails left over would be 1 minus 0.95 or 0.05. So each tail would be 0.05 divided by 2, which is 0.025, and this is 0.025. And that better equal 100%. So we're going to use, not the table, you can use your calculator, inverse norm, to find those critical values, or those z-scores, okay, corresponding to that c value. So if the level of confidence is 90, c is 0.9. So that means the two tails together are 10%, or 0.1, so each tail is 0.1 divided by 2, which is 0.05 and 0.05. So if I want to find what those z values are in my calculator, you can pull up your calculator, and in your calculator, second distribution, inverse norm, and I want my area left of this is 0.05. So 0.05. It's a z-score, so mean is 0, standard deviation is 1. And my answer is negative 1.645. So that's what that is right there. Since it's symmetrical, you really don't need to plug in the other one because it'll be positive. And if your calculator has the right, left, center, all you really need to do is put 0.9 and just say center, and it'll give you both those values. So the corresponding z-scores are just plus or minus 1.645. Sampling error. It's a difference between the point estimate and the actual population parameter value. So for mu, the sampling area error is the difference between x bar and mu. Mu is generally not known, and remember, x bar can vary from sample to sample. The margin of error is the greatest possible distance between the point estimate and the value of the parameter it is estimating for a level of confidence that the book will always tell you. I want maybe a 95% confidence or 98. So they'll tell you what that is. So here's what E is, the formula. Z of C, remember, inverse norm to find that. And then your sigma of the x bar. And remember, from last chapter, it's sigma over the square root of n. And if the sample is greater than 30, you can use the sample standard deviation. And remember, the sample standard deviation, you can find it at stat, calculate. I'm just showing you how to get it. You have to do this first to put it in your calculator. And there's your sample, 52.63. This is your population. Okay, so population standard deviation is the sigma. Sample standard deviation is the 52.6. And your calculator now has it, and I'll show you where that is. If you go to VARS, statistics, there it is right here. I'll just show you that it has that number in it. There's that 52.63. Okay? So it's in your calculator. So if you're using that, I would pull that up in your calculator. I wouldn't retype 52.6. So this is that same data that we just put in our calculator. So we're going to use social networking website data, 95% confidence. So it tells us our confidence level to find the margin of error for the mean number of friends for all users of the website. And we don't need to assume the sample standard deviation is about 53. We are just going to use what's in our calculator, that S sub x. Okay? So we don't have to type in 53. We're going to use what's in our calculator. So first, the critical values. Remember, the confidence level is 95. So this is 0.95. So the two tails together are 0.05. So one tail is 0.05 divided by 2, or 0.025. So now, in your calculator, you would do second distribution, inverse norm, and 0.025, 0.1 mean standard deviation, and that is my negative Z of C. Okay? And you know the positive is the same number, just positive. So 95% of the area under the standard normal curve will fall within 1.96 standard deviations of the mean. So now if I want to do this calculation, remember the Z of C is, if I want the positive, I'd have to negative inverse norm. And again, my C is 0.95, so that tail is 0.025. You could also put in your calculator 0.975 if you want the positive. That will give you the 1.96 positive. I'm just going to do negative inverse norm of that tail. So negative inverse norm, and again, 0.025, 0, 1, and then I'm going to multiply it by my S sub x. And when I did this data here, there are 40 numbers here, okay? And you can either count them, or maybe in the first page they tell you that there are 40 users, okay? So when I go back here, over the square root of 40. So let's put that in my calculator. Well, there's my inverse norm, the negative of it, but so I'm just going to do negative, arrow up, and grab this. I'm going to grab that whole calculation. So if you did negative inverse norm, typed it in your calculator, you know, the 0.05, 0, or 0.25, 0, and 1. And then now I want times bars, statistics, which is 5. S of x is 3. Divided by square root of 40. And you get 16.3. That's what you got in your calculator. Okay? And remember, you have to do calculate one variable statistic first, so it knows to throw your standard deviation into there. Confidence intervals for population mean. I'm going to take my mean now, and I'm going to add and subtract this value that I just got, because that's what E is. Okay? So the probability the confidence interval contains that mean is C. And remember, the 95% confident. 95% confident. So if I wanted to figure that out, skip this for now. I have my mean, and I have my E. So I'm just going to do my X bar minus my E, and my X bar plus my E. Okay? So let's do that. Here's my calculator. This is my E. So let's find X bar. Bars, statistics, X bar is 2, minus my E, okay, and plus my E. So I'm going to arrow up, grab it, and I'm just going to edit this equation. Just put a plus here instead of minus, plus. Okay? Oops, I guess it's 0.5. I wrote 0.4 here. 0.1. It's 0.5. I didn't change this. And this is 0.1. I wrote it there. So that's my interval. So I'm 95% confidence that the population mean friends falls between those numbers. So 95. And really, what they're really saying is 95 out of 100 of the confidence intervals will contain that mean. That's a proper way to word it. So college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20 students. The mean age is found to be 22.9. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean age. Remember this formula here. So first, I need to find my critical value Z. And I'm going to go to the next page because I think we know how, well, I will. I'll stop here or I'll do it. 90% confidence. So that's 0.9. So then this would be 0.05, and this would be 0.05. Okay? So to find this value, these values, you would do inverse norm, 0.05, mean, standard deviation. And that would give you your z values. And you don't really have to type them in and find them. You just need to know that. You just need to know that. That's how you do it for the formula. Okay? So I have my mean, which they told me was 22.9. So I have 22.9. And then I have minus my E. And my E, remember, is inverse norm, 5%, 0, 1. And then I'm going to multiply it by my S, or no, I'm not giving that in this. I'm giving it, my standard deviation is 1.5. So I'm going to multiply by 1.5. And then I'm going to divide it by the square root of 20 because there are 20 students. Okay? And then I'm going to do the same thing, but instead of this being a minus, I'm going to do plus. So let me get my calculator out and let's do that. 22.9 minus inverse norm. So we get that from distributions. Inverse norm, 0.05. And there's my inverse norm, times, and I'm going to put it in a fraction this time, just so you get used to using fractions if you want to use fractions. So to find the fraction, remember you would do alpha, y equals, and then push enter. And there's my fraction. 1.5 goes in the numerator. And in the denominator, square root of 20. So there's one of them. And my other one, change it to just a plus. Go over and change it to a plus. Oops. Too far. Yes. So it's between 22.3 and 23.4. Oops. Oh, sorry, 0.5. Didn't round properly. Okay. So that's my 90% confidence. Let me show you another way to do this. In your calculator, remember that under distribution you have distributions, but there's also, find it, stats. There's a bunch of tests under calculate. There's lots of tests. And notice there's intervals. There's Z intervals, there's T intervals, there's a bunch of intervals. You can go to, this one is Z interval. If you have the raw data in your calculator, you'd hit data. Like on the first example, you'd hit data. But if you, on this example, we're given the statistics, so you just do stats. And then you put in what you know. My sigma was the 1.5. And my mean was 22.9. And my N was 20. And my confidence here was 90%. 0.9. And notice you really get the same thing right there. Exact same thing. So you can do it with Z interval also. But I want you to know this formula because we're going to use that formula sometimes just alone. So Z interval is the fast way to do it. So interpreting the results, mu is my fixed number. It's either in the confidence interval or it's not. And you really don't say there's 90% probability that the mean is in the interval. You say if you collect a large number of samples, 90% of the intervals will contain the mean. That's a proper way to say it. So for example, 9 out of 10 of the intervals will contain the mean. And you can see if this is the mean value, the mean's in 9 out of 10. That's what it's got in. Okay, so there's a diagram of what we're saying here. So that's interpreting your results. And the reason I said I wanted you to remember that E formula is because we can use it to solve for n. Maybe we're given a confidence level and we're given an error, and maybe we need to find the sample size n. So if I take that formula and solve that for n, if I multiply each side by the square root of n and divide by e and then square my results, I get this formula. So these are the same formulas. This one's just solved for n. Okay? And if the standard deviation is unknown, you can estimate it using the S that they give you in the preliminary data. You have to have an n being greater than or equal to 30. So sample size, let's do an example. You want to estimate the mean number of friends for all users of the website. How many users must be included in the sample if you want to be 95% confident that the sample mean is within 7 friends of the population mean? Assume that the sample standard deviation is 53. So if I were doing this, remember this right here is inverse norm. 95% confident, so I can just use 0.025 and 0.01 for my mean and standard deviation. They're telling you the sigma's 53, but if you want, you could also use that from our calculator, okay? Let's see, within 7 friends, so that's my E value. So let's plug it in our calculator and see what we have. I have my Z value, so I have inverse norm, so second distribution, inverse norm. And on this inverse norm, remember we're 95% confident, so 0.025. 0.025. So there's that. And then I'm going to multiply by my 53, or you can use S of x. You just do 53 for now. And I'm going to divide by my E. Divide by E. And since I didn't put parentheses around the whole thing, because I need to square that whole thing, I'm just going to push enter. And then the squared button to square my answer. And let me just show you if I would have done it a little differently. If I would have done the same formula, but used my S of x, so let me go instead of 53. Vars, statistics, S of x is 3. Keep that number, so S of x divided by 7. Enter. Whoops. Go 2. Why did I do it? Oh, did I clear something? I must have cleared something. Calculate one variable statistic. I don't know what happened here. Let's try it again. Inverse norm times, it should work. Let's see if it's going to work this time. If not, type it in. Oh, there it worked. I don't know why it didn't work the other time. So there's that, and now let's square it. Okay? So there's at 217. When I did this one, it was, I typed it, the 53, it was 220, okay? So you might get a little different answer if you type in your own, okay? And I'll tell you what to use. If I want you to use 53, I'll tell you. If I give you data, then you have to use what's given in the calculator, okay? So inverse norm, and again, if you use the 53, you would have to use that fraction of a user. So if you put the 53 in, you'd say 221. If I gave you the S that you had to do, you would have said 218, okay? So if you would have used that S value, the standard deviation, and calculated it, you would have said 218. That's it.